All right, hello everyone. Welcome to another Wolfram language design review, part of our language completeness and consistency series. All right, first up, we seem to have a very old chestnut. Break is broken.
Yes. Right. So break is dynamically scoped, right? So sort of on the plus side, that means you can write a function that returns a break, and then you can use that in a do loop.
That's horrifying.
Right. So, right. On the minus side, well, you can write a function that returns a break that, right. So, if you pass in a function to another function, that might sort of expose the internal details of that function. So here's a resource function that's implemented using a do loop. And so this break in the second input, rather than breaking the do loop, it's the do loop you see, it's breaking the do loop inside of the resource function.
Okay, let's zoom out.
What it should do. It's named break. It's breaking code.
Let's zoom out for a moment, okay? Okay, so right now we have constructs like break, continue, return, okay? And one of the questions, and I mean, okay, we also have user assistance capabilities. So, for example, return could have the property that if you mouse over it, it indicates, it selects the thing which it is going to return from. That would at least give you some fighting chance of knowing what the hell the return was going to do.
That's a particular type of usage, though, where we're mostly concerned, I think, with programmatic usage.
What do you mean by programmatic usage?
People are using these in programs where they are not visually inspecting code or with a mouse or anything like that.
No, I understand it. But I'm saying when you write the code initially, it's a question of what is this return going to do? Because I often have no idea.
Because of the dynamic scoping, that you can't tell just by reading the code. Like in this example here, if you don't know what's inside table while, you have no way of knowing whether the break is going to where it's going to trigger.
Right. That's horrifying.
Well, it's historic.
I don't understand what this is. Well, hold on. What is this even doing here? You mean table while has a break inside it?
No, table while has a do loop inside of it. And so the first input works fine, but on the second input where the user has put in the break, rather than that break breaking the do loop that they wrote, it breaks
an internal do loop. Oh my God, that's so horrifying.
Right, which is why the third and fourth outputs are the same rather than it just returning the first three outputs.
Right. Well, first point is we can't change this function as such. It's been there for 35 years. We cannot change it.
Mm-hmm.
However, okay, so the point here is that this break goes into the hidden underworld. Basically, it breaks in the underworld.
Correct.
Yep. Okay. But it would be useful to have something which breaks the do you are currently writing. A lexical break, basically, right?
Right. So
and it's an error if it doesn't appear in a do loop.
Exactly.
I also wonder if it's useful to have labeled breaks and or break this particular function. Break, so return has an undocumented second argument that says, break the module or the block, don't don't return from, something inner.
Sure, but even if we do that, this double do situation will fool it.
Exactly, which is why I really don't like the idea of actually making use of label, but I'm wondering if that would actually be useful.
No, it's a no. It's a not good idea.
It's way too horrifying.
There are other ways to have control flow.
I have not wanted a go-to and a label in decades. I don't think I've wanted one in 35 years.
That is how
Yeah.
you would get around this issue if you really wanted to get around this issue.
Which issue? I don't even know where the go-to.
Where you break from. Instead of using
Yeah.
break, you'd use go to and label.
Oh,
how
no,
far does
but
it
I
go?
didn't mean to use go to. What
I
I
understand.
mean is other languages have the ability to label the loop so
Uh-huh.
that you can break an outer loop from within an inner loop.
Yeah,
Yeah, I understand.
that I see your point.
Okay, but hold on. Let me just understand go-to and label. Okay. I mean, I've not needed that functionality. I've not wanted that functionality because so maybe we just don't. Okay, but so the issue that we have here, and by the way, tags, throw is a great example, is a good example of a bad example of tagging. I don't think the tags in throw were a big success. I mean, they're useful for our internal implementation, but I think they're pretty hard to understand and they're pretty dangerous because it's like, some other piece of code happens to have that same tag in the underworld again.
Well, that's
you should use symbols as
really
your
bad,
tag.
bad luck.
What do you mean it's bad luck?
I
Luck
mean,
should not be part of the programming calculation.
Well, no, but the tag, if you, I mean, we don't make this super clear, but the right way to use the tag in like internal code is to define some symbol in some weird private context and use that as your tag.
And even a unique of that. Yeah.
yeah.
Right.
Yeah.
Right, but that's pretty horrifying. I mean, that's
Yeah.
that's a UUID story, which is perhaps the way that in modern times.
That's no more horrifying than the pattern matcher matches on symbols that you might declare in some, package or context or give it a name. It's no more horrifying than that.
It is more horrifying because it's a completely hidden state. It's completely hidden what's going on. You do a throw inside food code, so to speak, that's being fed to another piece of code. The piece of code that's being fed to, you don't see inside the animal it's being fed to. See what I'm saying? But somehow that animal somehow chokes on the food you gave it.
Although if that function happened to define a value for a variable in global, then you would have the same bad,
Fair enough. Fair point. Yeah, I mean, if you have but that's a visible side effect, whereas catching.
Yeah, I agree that, but I think it's more a matter of degree than a matter of kind.
I mean, you're making the argument against exceptions, which is yes.
No, I'm not particularly. I'm making the argument. No, I'm not. I'm making the argument, the following argument. In the case of a global variable, in a function, you're declaring something that has a global side effect. Okay? In the case of a catch, where you say, throw foo, catch foo, inside your function, right? You don't know that foo wasn't localized. And I mean, the truth is the way you should do it as module foo outside of the throw catch. Would that work? That would work so long as the throw catch is lexically in the code. But if the throw catch was
it would work because the foo variable gets uniqueified.
No, I know, but it would only work if the throw catch were both lexically visible inside the scope of the module.
But I don't see how that's different from just using a foo variable. It's just some weird thing from an internal context.
I agree. It isn't much different, except that that module has a semi-requirement to generate something unique. Okay, let's go back to this problem. Okay, so this problem is that right now you don't know that this function is going to choke on the break. Now, if we were to have what does break out of? Let's ask that basic question first.
Do while for, maybe scan. I'm not sure.
And
let's see whether it's
not scan, but I think do while, but or whatever the thing we added.
That's a good statement.
I would say that a recovery from this would be to have a thing called break do, break while, break for. Is that completely crazy?
Well, it just won't help if there's, double usage or more of.
No, I would say and have those be lexical.
Well, why don't we
That's
just
going to
have
be
break?
difficult.
Why don't we just have break lexical?
Right.
Because the
Um,
word lexical
the
is
impl-
extremely weird.
Well,
I
fine,
don't
think of
think
a
we
better
know how to
name,
implement it.
Why, instead of having 3 breaks, why not just have 1?
Well, but breaking, okay, first question is, okay, that's fine. What about continue?
Can continues fine as well.
What does it do?
Just
It's
It's going
the
to have
same
the same
three.
issue.
It's the same set of functions.
It'll have the same issue as break.
So, okay, so what continue is doing is going to the nearest enclosing loop operation.
Correct.
yes.
And something like it's only the pure side effect one. So a table doesn't have a meaningful continue, but a table could have a meaningful break.
I
Well,
think it could have a
no,
meaningful
because you have to know
continue,
what
actually.
would the table return. You know,
An unfinished a list that isn't as long as you thought it was going to be.
no, I think that's insane. Sorry.
I do not like that either.
Oh,
Doesn't throw, what does throw do in that case? It just because it just
Well,
I
it
see
just-
it.
Well,
Well,
it
it
can't
aborts
because
everything,
catch.
right?
you can't interpose the catch, so
You won't have your table at all.
it could never happen. The code's either executed or not.
Yeah, fair point.
If you throw out, from inside a table to outside, you lose your table.
Yeah.
Okay, so are there any other functions in modern times? Because this was from ancient times, right? This is a version 1 function. My God, it was
Right.
updated
Well,
in 1996. Well, that's something.
Well, there's some. I mean, this relates a little bit to. I remember around when we're talking about enclose and confirm stuff. One of the things that we did talk a little bit about was having like a lexical throw, and like a lexical catch or something like that. I don't know what their names would be, but it seems slightly relevant.
Which would only operate within the visible code.
Yeah. So I mean, it would sort of. I mean, it's a little bit niche, but I mean, basically, what it would let you do is right now, if you're using throw and catch, right? If you're using throw and catch and you're throwing, across many, functions and so on, then there's nothing you can do about that. If, however, you're using throw and catch within one function, like lexically together, I mean, right now, there are cases where you still have to use a tag because maybe there's some hold all stuff going on. But basically, this would mean that you can safely use them together, even if there is hold all stuff going on. There won't be a problem.
Well, I think that's an interesting thing. So I mean,
Hang on, this is what return. This is kind of what return is. It's like returning from the enclosing function.
yes,
This is what.
Right. Although you can't control as much where the return, like you might want to throw and catch. I don't know. You're mapping over something, and in each loop, you do have some throw and catch inside. The return only assumes that the catch is around the whole function.
right. Exactly.
Also, return is a weird, and kind
So
of.
you're saying the local throw
thing.
would.
Local
return-
throw is only caught by the lexical local catch that encloses it.
And it's an error if there isn't a local catch. It's an
Yes.
error.
Yes.
Yeah.
Same semantics as enclose and confirm.
And they have to be inside the same function.
Not necessarily. I mean, they just have to be lexically. The local catch.
Sorry, they have to be lexically related. No, sorry,
Yes,
excuse me. They have to
Yeah.
be lexically right. This isn't crazy. So sorry, I'm saying this isn't crazy.
Yeah, I
Okay.
agree.
So actually, I was going to borrow from our undocumented return. Maybe instead of one new function or 3 new functions, we have break of do, break of return, break of while, and break of for. That those have to be lexical.
I think it's a little bit
Have
crazy
dynamic.
if the break open close is dynamic, but break of do is lexical. I feel like that could be pretty confusing.
Although enclose and confirm have the same.
That's true, I guess. Yeah. Well,
Well, they
right.
do the
Well, with
opposite,
those, it's where
right?
you give them a tag.
Right.
I think if you give them a tag, I mean, it's basically saying if you give me the tools to be dynamic, I'll be dynamic, or like safely dynamic, I'll be dynamic, as opposed to just if you give me a function name, which has nothing to do with whether it's dynamic or lexical, then it'll become lexical.
Okay.
Yeah, although in this case, it doesn't know if it was lexical here with a pure break. It's a little less clear what the thing would actually break to, so to speak.
I mean, it's already unclear what the break is going to break to.
Yeah, well, I know. I have to say, I mean, what would happen? Okay, let's imagine we have a local break, local continue, local throw, local catch.
Is local the term for lexical?
I think the throw and catch are a different, pot of fish from the break and continue.
Why? I mean, because this would mean.
I mean, it's kind of also solving a different problem. I mean, because the thing with the throw and catch is just that there are a couple of fairly niche cases where throw and catch is sort of unsafe, and so you have to use tags and stuff, and it's a pain. I mean, alternatively, I mean, the problem with break, continue, etc., is more just these are kind of archaic and weird functions.
Well, the question is there a modernization of these that is meaningful? So hold on, let me just try something here because I don't even know what this does. Okay, so if I do this, otherwise,
honestly, my intuition would be that the value of break, continue, etc., is really in translating low-level code. I mean, if you're reading some pseudocode and it's written with for loops and while loops and breaks and stuff like that, it's useful to be able to just kind of translate that.
What the hell did this just do? So break dynamically on evaluation, I see, causes that to happen. Right?
Right.
Yeah, I mean, that's what it does. I mean, that did the right thing there, didn't it?
Yeah, I think so. So, I mean, but on the other hand, if I were to say,
right, and of course it broke before it got squared, right? Because power is not hold anything.
Mm-hmm.
But if it got squared, who cares?
Well, to try running this because it'll run the whole thing. Yeah.
Yeah, I think so. Now, what happens if I actually echo the break?
I don't think you'll see anything.
Yeah, okay, fine. All right. What was one really trying to achieve with break? And is there a more modern version of it? You're basically trying to.
There are certain. I mean, I agree that in the oftentimes it's because people are coming from C or Fortran, but there are matrix algorithms, for example, right, where you're starting in the upper left corner, where I don't know how you write them without do loops.
Right, but you end up with otherwise you end up with some kind of nest while type construct.
Mm-hmm. Yeah.
Well, anything you write with break, I mean,
is always replaceable with a conditional. Break is better. It's better to have, not to have to use the dreaded for loop and manipulate one of the indices, which is kind of what you could do with break. Though you can always implement break with a while loop and have a condition, while, flag, and then set the flag in the break. So
look, I mean,
it's difficult. Yes, you can, but you may want to break in the middle of it based on some condition that's just going to make it harder.
It's not unuseful, right? Yeah, there you go. That's not unuseful.
This will be useful.
No, I don't argue that, Tom. I think it's useful, but not sufficiently general to cover all cases. One uses it now.
Sorry, wait a minute. The ANAFA resolution didn't work for me. What's the this? Were you guys talking about this thing here, or are you talking about something completely?
Actually, I was saying the message was good. So not you want to. What do you want to see here?
I want to see the list.
A short list.
Yeah, shortened list.
Well, then you would have nothing instead of,
Well, you just wouldn't have that list there, or you would have possibly you return nothing.
But you would have if I greater than 3, nothing. Otherwise, I cubed.
Right.
Well, it would have to be throw nothing to the outer part of the table or something like that. But yeah.
I mean,
if you throw nothing, the table will just terminate.
No, not throw nothing. Make the return. Make the result of the if statement nothing. NOTHING.
Oh yeah, right. Then it will
That,
just
that won't work though. It'll still go on to the
No. Get rid of put the I cubed in the, put the I cubed.
Yeah, right.
Right.
Yeah, I mean, you can express this idea still,
Now,
right? But
that seems a more satisfactory.
By the way, we should probably have a link from break to nothing
Yeah.
in
Sure.
the documentation.
well, but none of the
Yeah.
functions that break works with right now return things where it's anything like nothing.
Yeah, it's
Right.
like twice removed,
Okay, fine.
if not thrice.
Okay, all right, fine. Okay,
There
this
is
is a
an
perfectly
open-
reasonable way to do this. What's that? Go ahead.
There's an open suggestion that we implement something along the lines of a loop protect, which would protect that inner loop in the example Itai first showed, I think, from break or continue.
Oh, I think this is so obscure.
Yeah,
Come on.
that's
mean-
that's in the
Easy
category
there.
of ship is sinking and you pump more water out.
Yeah, sorry.
I will disagree. I think it's in the category of, I have this function that's going to work on other people's code and I don't know what their code will do.
Right.
But the problem is we have a whole
Although
category.
if
of
we have
these.
the lexical break, then we've solved that problem.
Maybe.
Well, no, because people can still have the dynamic break. But I mean, I think that the more general problem is that we have a proliferation of these, abort protect and stuff like that. That there's like, if you want to be able to run someone's code in your code and be like, this is 100% totally bulletproof, it won't break anything. I don't even know. You probably need 15 wrappers before
That
can,
might be true, but in this case, you only need loop protect around loops.
Okay, but hold on.
Right, but
That
am I
particular
going
thing,
to?
being able to
Yeah.
safely run somebody's code, is a sandboxing problem, and we're currently in the process of making better sandboxes.
This will still be an issue, Stephen.
Look, it depends on how sandbox the sandbox. I mean,
Well,
if you put the onus on the sandbox,
I
I
think Stephen, I think you're confusing what is meant by safe here. I mean, sandboxing solves the problem of, I don't want bad side effects from this.
Mhm.
Danny and Christopher are talking about, I'm taking this input function and I still want it to evaluate in the way that both I and the user intend, and that my implementation details don't affect the user's implementation details.
Yeah, that's exactly right.
Yes,
I mean,
but
this is like for example, to use one other example, unevaluated, right? If you feed unevaluated to most functions, it breaks them in some bizarre and way that's totally implementation dependent. And it's like there's no, there are like probably 15 different kinds of things like unevaluated that can just unexpectedly break your code if someone gives it to you.
Correct.
And so
Yeah,
I think, maybe we could add more to protect against these other cases, but
Okay.
I kind of don't know how any of these are useful because I don't know when I'd use any of them.
Okay,
Unless I used
so
all of them.
basically, the basic point is there are things you can feed functions, black box functions that are poisonous to black box functions in unexpected ways.
That's a true statement.
Right? And understanding how to make something that is not poisonous, that could never be poisonous. I mean, the question is, if the eating function knows it's going to be fed something, how can it guarantee it's not poisonous? I mean, it could guarantee it, for example, by turning it into an abstract syntax tree. Then it's deeply inert.
Well, you don't necessarily want it to be inert. You might want to run it.
Yeah, I know. So that's the problem of sandboxes. If you sandbox completely, it's like the problem of,
Well, but you're not trying to sandbox completely. Like, for example, there was a bug because if you take confirm and you put an unevaluated into its nth argument, I don't even know which one, then it breaks a little bit, or it runs the thing twice, right? And it's like, that nth argument, maybe it still needs to run, it still needs to have side effects in the code outside of the confirm, etc. But it's just that there's a lot of kind of weird cases like that you can get yourselves into.
I understand. Okay, let's come back. Let's return to these things. Okay, so first point is local throw, local catch. I don't know whether it's lexical. Is there a better name than local?
I mean, another possibility is to have throw of local, like
Not a chance.
I mean,
Not a chance.
local
Not a
Alexa.
chance. Not a chance. We got to have a different construct, I think. I don't know what people
Is
think
there
about
anything
that.
from the confirm enclose world that could help if you're looking for names? Like catch
I don't
enclose.
think so, because they all just are implicitly lexical.
Yeah, but could you have like
I mean,
throw,
one
enclose throw and catch enclose or something? I don't know.
I mean, one fairly crazy thing. I don't, Tom. I don't know if this is what you were suggesting, but you could have the tag be something special.
That's
Like
what
you
I
say,
was
throw
suggesting.
of whatever,
That's
and
what
then
I
the
was
tag
Nobody's
suggesting.
ever going to
is
figure that
some
one out.
local thing. Yeah, and it's also probably going to be. I mean, one of the. It sort of also defeats the point, because the advantage of this is that it basically lets you not use a tag in a few instances.
Yeah. You see, this would be a nice way of bailing out of a scan or a map or a fold or something.
Right. Look, I think we should consider local throw, local catch. Okay. And
how do they fit in with the other revamping of handle and raise and things like that? I mean, they should be more modernized, surely.
Well, I think these are a little different. I mean, the stuff, if you're talking about the error handling stuff, I feel like that's. I mean, right now, throw and catch are one of the main exception mechanisms. I think the raise and handle or whatever, I don't even remember what they're called. Those would be kind of a new exception mechanism, and these new throw and catches would be sort of relegated to the other use of throw and catch, which is just kind of small scale control flow.
Yeah.
Right.
That's correct. I believe it might still be useful. It's a little bit off scope for the question at hand, although it might be useful in its own right.
Okay, so look, I think it's useful in its own right, and I think we should look at implementing this. But let's talk about break. Let's talk about break, because I agree that we need a version of break that just breaks out of the lexical, the lexical do that it is.
So what's the problem we're solving though? Is the problem that we're solving that people are afraid that they're going to write code with a do in it and that it's going to be unsafe? Or are we fixing the problem that people will put break into a piece of code and it will break, if you know what I mean? Like because the point is that, if, for example, we add another function called, better break, and then maybe we deprecate the old break. I mean, is that kind of enough? Like, is that what we're trying to do?
Yeah, I think so. I mean, what I think we should be doing is, let's say we have local break and local continue. And all they do is they do the lexical version of breaking out of the lexically enclosing do while for.
That sounds fine.
And that way, I think we should look at doing that. Local break, local continue, local throw, local catch.
Why don't we have local return then that does the same thing in functions?
What's it going to return out of?
The enclosing function.
Does return already do that?
Well, it has all sorts of weird, astonishingly weird extra functionality.
The two argument form, Tom's correct, but in every sense, the two argument form can tell what function to break out of, but it's still not lexical.
No. We should have a lexical thing. It's very obvious what the enclosing function is.
For what?
It is?
For return.
For return.
Why is it obvious?
Does
it go out to the down values? Wait a minute. It goes out to the place where it hits a down value. Is that correct?
It would return from like the nearest set delayed or function with a capital.
Or function.
It says function.
I'm a little scared of because I mean, if you map over something and you return in the map, I'm not.
No.
Maybe it should return from that.
That's why you would use local throw and local catch.
This doesn't.
I mean, this is why I'm skeptical of return in general, is because you can basically always get the behavior of return with throw and catch, and it's just more explicit what's going on.
Well, you can get the behavior of two argument return with throw and catch. I don't think you can get the behavior of one and
I mean,
zero
sorry,
and one
it
argument
was
return
utterly
anything
obvious.
else.
No, I think what he meant is you got
Obvious.
what you
no
wanted.
discussion what the implementation of return should be. Sorry, we just,
Well,
it's just
hold on, Tom. You say that, but you made a comment about function, like the
I
function.
did.
function.
It says function. Look at the
Yeah.
page. It says function.
Yeah.
We have two notions of function. We have lambda functions, anonymous functions, and we have named functions.
Yeah, okay, but what is this?
I mean, what are we even discussing?
Okay,
So
Sorry.
in this case, it could be a module.
No.
No,
We
a
have
module is not a
functions. You make
function.
them with set delayed. They're down
okay,
value.
so wait, hold on a second.
That's
Does
what
it return from a pure-
99.9999% of our users
Okay, hold on,
imagine
hold
we
on.
mean by
Does it
functions.
return from a pure function?
Yes.
right now.
Oh,
In the
God,
current version,
maybe.
yes.
Who knows?
It
Well,
will
if
also return
it-
from a
Tuesday.
module.
If it's Tuesday, it does, and if it's Wednesday, it
No.
doesn't.
So wait a second. If hash is greater than 3, return foo. Okay. Okay. So
Else.
now I'm going to do
Put,
this.
put that in
And,
a down
the-
value though.
I don't want to put it in down value.
He's
fine.
testing the
No, it just does the obvious thing. It doesn't return from that function.
I'm not sure that is the obvious thing,
No,
but
no,
it's
I-
a thing.
So hold on. Let's do this.
I think that's
If
close
hash
to
is greater than
correct.
3
by the way.
wait a minute.
Well, I think the thing is, right, a lot of languages, when you have sort of an anonymous function, it's just like a normal function in the sense that returning from the anonymous function, calling return to the anonymous function returns from it. But I think there may be two differences. One is that in a lot of those languages, their syntax for defining an anonymous function is very similar to their syntax for defining a named function, and they're kind of more similar. And so it makes sense that return has the same behavior between them. We don't really have very similar syntax. The other thing would just be that, we do have really a lot of kind of little anonymous functions everywhere that most other languages don't have.
Right. Look, this seems very bizarre and arguably wrong, and certainly not documented.
Well, it's
Wait, no, it
returning
did
from
not
the function.
return.
It's
It-
returning
this-
from
this-
the function, but not the map.
I know that.
No, return did nothing. Return did nothing, right?
No. But look, it didn't do nothing.
Put a
This is part of
semicolon
the-
after the return. Put return semicolon 3.
Yeah. This is part of the
I'm
design.
sorry, I don't
that
understand. I
Tom
don't
was
understand.
talking
It
about.
didn't do nothing. Look, why didn't it just follow on in the compound expression and give squares?
right. It actually did
Oh.
return. Right.
It
But
did. It did
why-
something very bizarre.
Why to
Right.
return of foo?
because that's what return does when it's not inside of anything, right? So if you just evaluated return of foo by itself in an input cell, you'd get
Well, if
return
I
of
say
foo.
one,
But if it did
return-
actually return, this seems like it could be a bug. If it did actually do
I-
some returning behavior.
It's not, I don't think return is even localized to a function. I just sent you an example, Itai, where we have a return inside a function and it leaks out of the function.
Okay.
Like I just sent you an example where you have a function passed to a function. One uses
Did you
return
send
and one
me a
doesn't.
function?
So I just sent it by email.
via
I just sent you a
email.
notebook. Yeah. I just sent you
Okay.
and if you have this, if you call that function in a loop, then the one with return breaks out of the loop and the one without return doesn't. So it's just, even though it's defined inside a function. So I don't know if you want to share that or not. But I don't think it's even localized properly.
This is a different issue though. What is going on with that example with the return of foo? I just don't understand.
crazy.
It seems like that would be a bug. Because
Well,
it
is this
seems
what
like
Tom
it is
said it
actually
should do?
returning.
It's what Tom
No,
said
it's
it
not.
would
He
do.
said it should return 149 foo,
Correct.
not return of foo.
Correct.
That's even more bizarre.
Yeah, this
No,
comes
it's not.
out to those.
No, not
weird
at all.
semantics.
You're returning from the function.
But what are you returning?
You're
Foo.
returning the payload of foo. You're
Yeah,
returning
returning
payload.
foo.
Okay, but you think this is a bug. So you believe this is a bug.
Yeah,
It's a bug, but it is so legacy.
I think it's endemic to our implementation of return.
Yeah.
It's also something that would be extremely hard to fix. It would probably break the world. because
Okay.
there's so much code that depends on these weird vagaries.
Okay, we're not
But
touching.
you shouldn't
what
be
return-
relying
Well,
on
let's
return
not-
being returned. You shouldn't be relying, Dan, in your code on return being returned from a function. That's just,
Exactly.
I mean, if you're relying on that, you've really done. What other language allows you to
I
return
agree
return
with you,
statement?
Mark. I agree with you.
I mean, that's just
Years
quite
ago, I
frightening.
tried to change this, and the amount of damage it did was horrifying.
Okay, so let's just review what it is we're actually saying here. You're saying there is a notion of returning up to a, there's return up to a colon equals, return up to a set delayed or something, set or set delayed. Actually, it has to be a set delayed, doesn't it?
No.
Yeah.
Why does it have to be a set? Oh, because it would
Because
evaluate.
otherwise,
Because it would
Right.
have been evaluated.
Yeah.
right. Okay, so that's notion number one. Notion number two is return inside a function.
Capital function.
Right. And which I claim, I mean, clearly it's broken here. I mean, it's been broken for 3 decades, probably. Now, I mean, I claim that if you see return, I would expect it to just really go to something well-defined, like this is horrifying. If you happen to put your return, you thought it was going to be a boom, I'm returning up to the set delayed, but you happen to have that return inside a function, it would shield it. I bet I've run into this bug.
Well, you could have a set delayed inside a set delayed. It's the same thing. I mean, come on.
Wait a minute. Can you? Wait a minute. Wait.
You can.
Yeah.
You definitely can, but it's not very
Yeah.
common. It's much more common of a pure function inside of a set delay.
I think we should be lowering the boundaries between set delayed functions and lambda. The only difference should be one has a name and the other doesn't. We should break these boundaries.
Wait,
enhance
Tom,
them.
there's a
They're
huge difference.
confusing.
There's a huge difference. Our set delayed type functions are transformation rules. Right now, function
Detail,
functions,
that's
no,
some
it's not a
detail.
detail. It's not a detail because right now our function is an omnivore. Right? You've changed that a bit with types.
I think
But
that's
we've
still
never had, hold on,
detail.
we've never had, no, it's not a detail at all. We've never had a mechanism to have a function, look, that eats, where the thing it eats, I mean, we've talked about having such a mechanism, where if you feed it 4, 5, where we give some syntax here, like, for example,
It's called
Um,
replace, by the way, if you want a thing for
yes,
an anonymous replacement rule.
It's like a terrible weakness that we certainly could support syntax like that. It would be very useful, actually. People put set delayed inside other set delayeds to get this sort of behavior.
Okay,
There's no
there's a
reason
separate
why it
discussion.
couldn't.
There's a separate discussion.
This is
which we should have.
totally agree with that.
Hold on. That's a separate discussion. We've looked at this multiple times. There are all kinds of issues with it, but we can certainly look at it again of
I
having the
think
possibility of
we-
wait, of having the possibility of patterns inside functions. But let's review for a second, please, the
Yes.
thing that we actually were supposed to be reviewing, which is return. Okay. And to me, it seems like there is a well-defined notion of return, which is return to the nearest enclosing set delayed, which would be the analog of local break, local continue. If somehow, I'm still a little bit confused whether the code you're running always has, I mean, would there be any sense in having some differently named return that definitively just goes to the nearest enclosing, set delayed?
Maybe, yeah.
Does anybody know, by the way, whether our stream failed? Anybody?
You mean the
It
live
It looks like we're
stream?
still live.
Okay, fine.
Um,
Okay.
right. I mean, I kind of agree with Tom that if we have this new construct, that it would make sense to put function and set delayed on an equal footing. I mean, right?
I'm not sure I agree with that, but look, the basic point here is, okay, right now, okay, the first thing we were dealing with was break and continue. I think we've got this concept of local throw, local catch, local break, local continue. So at least we've got a solution to that, a lexical version of that.
Right.
Now the question is there any change we want to make to return?
Right. I think in the past, I mean, right, this is certainly not the first time we've discussed this, although it's the first time in a while. I think the name we sort of came up with in the previous iteration is that the new version of return would be return from. But that seems a little weird if we're
very weird.
Yeah.
Well, you'd say what, return from of foo, where foo is my function with down values.
Yeah.
Yeah.
Maybe it should be called like function return, but if we call it function return,
then what does it do with pure functions?
Right.
Yeah.
All right, let's have that on a separate agenda.
Yeah, fine.
I want to cover. Okay, so we've got local throw, local catch, local break, local continue. Let's try and implement those.
Right. Those aren't the names though, right? Or those aren't the final names necessarily.
Not necessarily. If we can come up with better names.
Fine.
Okay.
Okay, let's have a quick look at we've got several important things here and we're going to run out of time. I want to look at supplied just from do you guys have good things to say about this? Have you really been working on this one, manipulating held expressions?
No, because we were well, I think there was a little bit of a breakdown in project management, but also we had sort of just started on sort of the next thing about these other things, and we haven't really gotten anywhere.
Let's look at supplied.
Right. So the big thing here is this more comprehensive list of functions where we might want them. And they're sort of two sets, the ones where it wouldn't make sense to have both contextual variables and supplied, and the ones where it only makes sense to have contextual variables because supplied really wants to surround a function.
Right. Well, it could surround a rule as well in the replace family.
We decided against that.
Why? Supplied on the
because what do those things bind to?
Say that again. Explain that again. So I mean, in the case of a function, a pure function, what we would be doing is we'd be saying supplied of
right, like list, index, comma.
I think this is one of the original reasons we started talking about contextual variables, was that it would be I didn't know that was the term we were using, is that you could basically just bind them to, they can just be sort of always bound things that you can use on the right hand side of the
no, the idea was those could be pound 1 and pound 2 now, right?
Well, no, that's what supplied does, but the contextual
right. Yes, that's what I'm
variables
saying. I'm talking about the input Stephen Stephen just typed in, right? That pound index plus pound data should be pound 1 plus pound 2.
So the point is, if you had a rule, right, this is an example, right? You have some payload, and then you have your replacement rule is something like,
X blank goes to index plus X, or $$ index plus bank, right? If you tried to write that as supplied, that wouldn't make any sense because there would be nothing to hold the string index.
I see what you're saying. No way to refer to the string index.
Right.
Right. Now here, why isn't this building an association of these things? I mean, it seems to me the code would be much easier to read, mostly, if that builds an association in this case. You say this.
Right. Well, the idea was that we could, could, and maybe that was going to be one argument. I think we maybe talked about that being a one argument supplied, right? But the idea
Yes.
was you could use supplied, right? You wouldn't have to rewrite your function each time you changed what, right? If that was going to be, you know, arctan, 2-argument arctan, right? You could just do arctan there instead of arctan of pound index comma pound data, which would be a really stupid function, but you get the point.
I'm not sure I do. I mean, this what we said is that supplied would lexically figure out, in a case like this, what things it has to supply based on the names of these variables.
Right.
Then
But
we
in-
went from that to this idea of just having variables that hang out there.
Right. But they're right. And the supplied with the named strings, the 2 arguments implied is precisely so that you can take, you know, predefined down value based functions and feed them in and adapt what are the inputs based on the context that you're feeding that predefined function into.
Sorry, go ahead. Yeah.
Well, sorry, I was just going to ask one other quick thing, which is with the contextual variable stuff, was the idea that those would be lexically scoped?
I
Or have we
think
not gotten that far?
I think we decided that those definitely had to be lexically scoped.
Yeah, I think they have to be, because otherwise
Okay,
it's really,
So if they don't appear, they don't get bound.
that's correct.
Exactly.
Good,
Yes.
okay.
Because there are lots of these
This would
variables.
be astonishingly expensive to do this
Right.
in remap, you know.
Right. But so where are we at with the idea of $$ index, $$ data?
So we consider, so as it says, I mean, implementationally, I don't think, right, we had that prototype, no, for $$ index, I don't think we've had any sort of implementation. And last time we considered replacing that with, you know, that different full form.
Yes, I like that idea. I think that well, in fact, if we were going to do that, it would make more sense to have some kind of other prefix form here that prints. I mean, I don't know what we have available, but we don't have a lot available anymore. I'm looking at my keyboard and trying to see what might be available as a prefix form.
It's always scary. You know, one of the problems like at the summer school, we've had this where, you know, we'll use some weird symbol like a tilde or something. And people have international keyboards and they don't have that symbol.
Yes.
The worst
But I mean,
is the Swedish keyboards where to type a square bracket, I think you need to do like Option Shift.
Alt GR.
Yeah, right. I mean, who knows what the you know, let's imagine, you know, exclam question mark X, let's say, or whatever it is. That is a syntax that means contextual variable. I mean, does this make semantic sense to have something like this that is a lexical object that appears in a pure function in a way that is to be supplied by, if the pure function, I mean, are these well defined? Do we know what the variables are for each one of these functions? Like, for example, let's take the example of nest graph. Okay, let's say we have one of the variables means the iteration number. For nest list, that's very well defined. For nest graph, that's much less well defined.
So, I mean, I think though that they don't necessarily, like, it would be nice if we can use the same names of these variables between lots of functions, but I think it's not necessary, right? I mean, each function map will still have its own documented table of here are the contextual variables I supply, and nest list will have its own list. And they might happen to align
Yeah.
in nice ways.
Right, which is part of why we tried to group them this way. I mean, these are things, sort of each bullet point are things that we think are likely to have the same or mostly the same contextual
Okay,
variable.
so I've got another point that's similar to this. Okay, things like, between mesh functions, vertex shape function.
Yep, that's on our
discussed
list. On that's like the last three or the last and anti-penultimate bullet points, right? Region function is there and mesh function is there.
So hold on though, but by the way, I mean, so there's one slightly weird thing that's happening though, which is that this contextual variable is slowly turning into another version of lambda functions with named parameters, just like feeding an association to an existing lambda function. Because basically, you'd imagine that if we have proper support for these, we'll have some outer function that lets you basically, give the we'll have some outer function where you give it, say, a pure function or some other piece of code, and it will, and then you give it a set of, say, replacement rules where you tell it, if you see a contextual variable index, evaluate this function to find the index or something like that. And you'd have to, it'll probably, like, this is extremely similar to function application. So I don't know.
It's function application with kind
it's
of
slightly different, I guess, because it's lazy in evaluating the arguments. And I guess maybe, at least in terms of the internal implementation of things like map, you'd want it so it doesn't have, you'd love it if it didn't have to scan the input function more than once. But
look,
yeah.
basically, this is a footnote to a function. It's in addition to being fed its main, I don't know why we're talking about food so much, its main argument, right? Its main food. This is some kind of, it's some kind of seasoning on the food, he says. It's some additional piece that's coming in and being referenced within the body of the function by this contextualized variable thing. But I don't quite understand how it. Okay, we've run out of time here. We need to continue this. I think we should have a complete custom meeting about supplied. This is going to definitely take a whole session to go over this. Make sense?
Okay.
Can I just ask, is the point of it to gather information when you traverse these specific functions?
Yeah. For example, with map. Okay. Right now we have map and map indexed, right? But we can imagine more general forms of map indexed.
Right. And also there's a whole bunch of, should we have a scan indexed too? Like there's a whole bunch of functions. There's a whole combinatorial set of these,
Yeah. And we ran
like
into this for tree map because tree map has this, do we need a tree map indexed and so on? And I'm not a big fan. Yeah, go ahead.
Sorry, I've got a couple of questions. I'm just trying to get a conceptual idea of it. But it doesn't change the way that you iterate through it, like the pre-order, traversal, post-order. It just gathers the information of whatever the iterator through that object is doing.
For example, yes.
Okay.
I mean, it could. So, for example, right. I mean, the term index versus the term position index, although we've, could mean just the top level, first level index. Position means the whole, list that gets provided in map indexed and so on. Anyway, I need to go, but to be continued, guys. Can we get a complete meeting about supplied, please? Okay, I'm going to disappear. See you guys later.